Hello and welcome back to Miles Maths. This is the first of a series of videos on transformations of graphs, and this particular video is going to deal with translating graphs. Let's look at some basics to begin with and just consider the equation y equals x. We'll be using Desmos throughout this video, by the way. So the first thing to consider is what happens to y equals x if we change it to y equals x plus 1. Well, from your work on straight line graphs, you will know that this is a straight line graph of gradient 1, and that the intercept is also, the y-intercept is also 1, so these two lines are parallel, and clearly the effect of adding 1 to the end has just been to move the line effectively one place up the y-axis. If I change that to y equals x plus 3, clearly all I've done is moved it 3 places up the x-axis, and the y-intercept now being 3. And if I decide to take y equals x minus 4, again I have a parallel line to y equals x, except this time it's going through minus 4. So what we can establish here is that the number that I put onto the end here, the y-intercept, all that does is move this straight line up and down the y-axis. Well, when we start to talk about translations of graphs, we really shouldn't be surprised that if we start with y equals x squared, that if we consider the graph y equals x squared plus 2, this is simply a translation. All we've done is moved the graph and given it a y-intercept of plus 2. And so we can see this quite clearly here, that the graph of y equals x squared has just moved 2 places up the axes. We can also consider what happens if we consider y equals x squared minus 4, for example. You might be, sounds obvious, but it's now going to have a y-intercept of minus 4. So all we're going to have done is translate this down the y-axis by 4 places. So effectively what we've done here, when we considered y equals x squared plus 2, we moved this by a vector 0, 2. When we considered y equals x squared minus 4, we moved this by a vector 0, minus 4. That is to say, 0 places left and right, 4 places, minus 4 places up, which is 4 places down. The difficulty comes when we start to consider things like y equals x plus 2 all squared. So let's draw the graph of that and see what happens. So we notice it's the same shape as y equals x squared, except it's been moved 2 places to the left. So that implies that this plus 2 in here moves us 2 places to the left. So it moves us the opposite direction, and it's also now not moving us up and down, it's moving us left and right. So let's consider what we should think happens then if we obey the same rules with x minus 5 all squared. Well, if plus 2 sends us 2 places to the left, we'd expect minus x minus 5 all squared to send us 5 places to the right. And lo and behold, it does. So what we can say about it, when we have this number inside the function, by inside the function, what I mean here is this plus 2 is outside the function. The x is squared and I'm adding 2. Here I'm taking away 5 and then I'm squaring. So we call this inside the function. Inside the function, we move left and right. Outside the function, we move up and down. Inside the function, we go the opposite of what you'd expect. Outside the function, it does exactly what you'd expect. So if we then consider y equals x squared plus 3, what do we think is going to happen? Well, is the plus 3 inside or outside the function? What's it going to do to that original y equals x squared? It's outside the function. I'm not squaring the 3. Hence, this must be moving it in the y direction. I'm going up and down in the y direction. And it's doing the obvious. It's going to move up 3 places. And here's the line. We can see it there. They're both black, unfortunately. With this one, I've now got y equals x minus 2.5 all squared. Well, minus 2.5 is inside the function. I'm going to be squaring the whole thing. Hence, this is going to be left-right in the x direction. And of course, it's minus 2.5, and it's going to do the opposite of what I would expect it to do. This means we're going 2.5 places to the right. Let's draw the graph. There it is. Excellent. So this works obviously with all functions, not just straight lines or quadratics. So let's consider y equals x cubed. Here it is. What do you think will happen to y equals x cubed minus 1? Have a think about it for a second. What do you think is going to happen? Yes, the minus 1 is outside the function. It's outside the function, so we're going in the y direction, and it's negative, so we're going negative. We're going by a vector of 0, minus 1. So we should find that this point here ends up here. Let's just try it. Whoopie doop, it does. On the other hand, if I considered y equals x minus 4 all cubed, so this minus 4 is now inside the function, we would be expecting this to do the opposite of minus 4. The opposite of minus 4 is plus 4. So I'm expecting it to go 4 places to the right. So I'm expecting this point to end up here, sorry, starting here to end up here. So this is being translated by the vector 4, 0, because it's not moving up and down. Let's just see that. And there it is. So the graph remains exactly the same shape. We're just moving it around.
Okay, what we're going to do now is just go through a few worked examples on translating graphs. So here's some typical exam questions. Here's the graph of f of x equals x squared. Sketch the graph of f of x equals x squared plus 3. Well, let's look at what we know. We know this translation, which is adding 3 on. So we know that this is in the y direction. We know the y direction things just happen as they're supposed to. So as this is x squared, it's going through 0. So this will be moving 1, 2, 3. It will be moving to here. Are there any other points I could look at? Well, this point here will be moving 1, 2, 3 squares to here. And this point here at minus 1, 1 will be moving 1, 2, 3 squares to here. So I'm looking at a parabola that goes through there, down to this point here, and back up the other side. Can I point out that I'm doing this in pen? You would do this in pencil on a GCSE paper. You should assume that it will not be marked unless it is in pencil. I'm only doing it for clarity so that you can actually see it a bit more easily. Sketch the graph of f of x equals x minus 2 squared. Well, I see the minus 2 here. I'll do this one in a different colour. So I see the minus 2 here. Is inside the function x minus 2 all squared. So I'm transforming x squared, and the minus 2 is inside the function. That means that this is in the x direction, and it does the opposite to what I'm expecting. So rather than going minus 2, it goes to the right 2 places. So if I take the turning point here, the turning point here will end up there. This point here will end up 1, 2 places to the right. This point here will end up 1, 2 places to the right. Are there any other points that I might get onto my curve? This point here will end up 1, 2 places to the right. Obviously this point's going to run off the side of the graph, but I can now see that this would look something like that, and we can see the parabola has moved 2 places to the right. Easy as that, not a problem. F of x equals x squared is translated by the vector 0, 6. So now we're given a vector that it's translated by. Well, is this an up-down vector, or is it a side-to-side vector? Well, it's an up-down, isn't it? I'm not going up 0, 6 is that I'm not going right or left. I'm staying where I am, but I am going 6 up. So f of x squared is translated by the vector 0, 6. And if I draw myself a set of axes that look like this, I'll draw them sort of vaguely so that the origin's in the middle. All I need now is a parabola. I know what y equals x squared looks like, but I know that it's not the y equals x squared through there. It's been moved up. It's going through a point around here. So I can just sketch that on. Not a very good sketch. And it's going through the point 0, 6 because the origin has been moved. Or I should say the origin has not been moved, the origin's still there, but the graph would have gone through the origin and it's now been moved using the vector 0, 6. So this is the graph of y equals x squared plus 6. It's a sketch, but I'm going to put on any points that I know. So I know this goes through 6, so I'm going to put that on. I'm also going to just, oh dear, that'll teach me for doing the wrong way around, labelling the wrong way around. So x and y. Let's look at some more examples. f of x is x cubed is translated by the vector minus 8, 0. Sketch the new graph of the transformed function. Well, of course, it requires me to realise that x cubed looks kind of like that. If you don't know what the shape of x cubed is, you're stuck to begin with. So you've got to make sure you know the shapes of your functions. And once again, it's a sketch. You would do this in pencil. Get that right first time this time. And f of x is x cubed is translated by the vector minus 8, 0. So minus 8, 0 would bring it down here because it's being translated by this vector. So this is going to be minus 8. And I just need to make that axis a little bit longer now. I just need now to put this x cubed on here like this. And there we go. And this is x cubed translated by that vector. Y equals f of x has a minimum point at 1, 3. Oh, this is interesting. So it's got a minimum point. So we know this is some sort of curve that only has, might not be a parabola, but it only has a single minimum point at 1, 3. Give the coordinates of the minimum point of, and it then gives me some different functions. Well, it doesn't ask me to sketch it, but actually sketching it might be quite a useful kind of thing to do. So I don't need to do a sketch for this, but I'm going to, just because I think it might make it easier for me. So f of x has a minimum point at 1, 3. So 1, 3. Let's say 1, 3 is there. And there's my curve with a minimum point at 1, 3. That's the original function. Give the coordinates of the minimum point of f of x plus 4. Okay, so f of x plus 4 will be this graph translated in the y direction, because the plus 4 is outside the function. So in the y direction by 4 units. So it's going to be up here somewhere. So what's the location of this point? Well, clearly it's 1, 7, isn't it? So I can say 1, 7, because I've moved this point upwards by 4 units. Hence 4 plus 3 is 7. Give the coordinates of the minimum point of f of x plus 1. Okay, well, f of x plus 1. The plus 1 is inside the function. So it's in the x direction. It's also doing the opposite of what I expect. So it's going one place to the left. So if this was the point 1, 3, this new function will be there. It'll be some sort of curve. It'll look like something like that. And this, of course, is the point 0, 3. So that'll be the minimum point then. So 0, 3. Good. This is all working out very nicely. And then finally we have y equals f of x minus 3. Well, again, this is inside the function, so this is a translation, but it's inside the function, so it's in the x direction, but it's the opposite of what I'm expecting. So it's not going left 3 places, it's going right 3 places. So this is going to go 1, 2, 3. We're going to end up somewhere over here. My graph's going to look a bit like that. And I'm going to have moved 1, 3 places to the right, so this is going to be at 4, 3. So whilst I didn't need to sketch the graph in order to do it, it gave me a little bit of help. It gave me a visual reference point for doing this kind of work and these kind of problems. So finally then, finally 2 more examples. F of x minus 5 has a minimum point at minus 2, 7. Now again, I don't need to sketch this, but I'm going to, just because, well, it seems like a jolly good idea, really, just to sketch it. Clearly, minus 2, 7 is quite high up. Let's take a chance and just do a sketch that kind of looks like that. So minus 2, 7's got to be somewhere up here somewhere. So, and that's a minimum point as well. So that's fine. If it was a maximum point, I'd just draw the graph the other way up. So this is of f of x minus 5. So where was f of x? Well, this has been translated by minus 5 outside the function. So it's been translated in the y direction, negative 5. So in other words, the original function, so this is the point minus 2, 7, the original function, which we'll do in black, must have been 5 places higher than this. So this must be the original f of x. And if this is 5 places higher, this must have been minus 2, 12, because 7 plus 5 is 12. So that'll be minus 2, 12. Good. Where is f of x plus 1? Well, f of x plus 1 is clearly just above f of x. It's just a translation in the y direction of plus 1. So f of x plus 1 must be there. And this point here, I'll have to put an arrow into that one, must be the point minus 2, 13, drawn over my y. Never mind. Bear in mind, the sketch isn't being marked. It's only the answers to the question that are being marked. So my sketch doesn't really matter. It can be a little bit of a mess. Nobody else is really going to see it or use it or want to use it. And then finally, y equals f of x minus 3. Well, f of x is the black one here. And minus 3 inside the function means I'm going 3 places to the right. So if I'm going 3 places to the right, I would be going minus 1, 0, 1. So my minimum would be there. And this point in here, therefore, would be the point where clearly it would still be something 12. And I've gone minus 2, as I say, minus 2, minus 1, 0, 1. So it would be the point 112, wouldn't it? That's excellent. So now finally, example 6, the graph of y equals f of x has a maximum point, well here we are, a maximum, look, at 3, 5, shown. They've given me a little diagram. Give the coordinates of the maximum point of y equals x of minus, f of x minus 4. Very similar to the question above. It's minus 4, so this is inside the function, so this is going to the right by 4 places. So this point here is going to end up somewhere over here. It's going to end up 4 places to the right. I'll just sort of sketch that in, and therefore this must be the point 3 add 4 is 7, 7, 5, because I've gone 4 places that way. So that's great. So I can say this is going to be 7, 5. So give the coordinates of the maximum point of f of x minus 4 plus 1. So that's this graph, but I've translated it by plus 1 in the y direction. So what I'm getting for this part here, so I'm getting another point that's just above it. It's been moved up 1 and it's sitting there. So this coordinates of this point must be 7, 6, because this graph has been moved up as shown there in the y direction. And if you can do those examples, you will be able to do the typical GCSE questions. Well done.